anymore because I can just do it all. Okay, here we go. So let's take a look. There is nothing, we're not learning a new definition today or anything like that. We are applying the fundamental theorem of calculus, and we will be doing that for the next few days. Okay, we're going to apply it under in different kinds of problems. So if you'll take a look here, it says, given dy dx equals 3x squared plus 4x minus 5, with initial condition y of 2 equals negative 1, find y of 3. How have we been doing that problem recently? Like in this chapter right here. We've been integrating, but what did we do before we integrated? We separated variables, correct? We separated variables. Are there any y's to move around? No. So we got 3x squared plus 4x minus 5 dx. And then we integrated both sides, right? And so we ended up with what on the left? Y equals x cubed plus 2x squared minus 5x plus c, right? And I was given a what? I was given an initial condition, right? And that initial condition allows me to find c. So let's do that. So y of 2 is negative 1, so I'm going to set negative 1 equal to 8 plus 8 minus 10 plus c, right? And I'm going to get that c is equal to negative 7. So y is equal to x cubed plus 2x squared minus 5x minus 7 is called the what? Yeah, it is the solution, a particular solution to my differential equation. And what can I do with that solution now? Use it to find other y values, right? So I was asked to find y of 3. So y of 3 will be 27 plus 18 minus 15 minus 7, 23. Okay. So that is one way to work this particular kind of problem. Notice I'm not finding a, I haven't actually just been asked to find the solution at a point. I've also been asked to find the y value at another value of x, right? Well, another way that you can do this sort of problem, and we saw it come up one time in your 6.4b questions. Do you remember I said we're going to do more of this kind of problem at the beginning of chapter 7? Well, it has arrived. Okay, so the second method of working this problem says use the fundamental theorem of calculus to work this same problem. So are you in agreement that if you integrate f prime of x from a to b, that will turn into f of b minus f of a? Yeah, I mean, that's by definition, right? That is a definition of fundamental theorem. So go back and look up here. Have we been given f prime? Yeah. Have we been given a point? Yeah, and we're looking for the y value of the other point. And this method is actually a lot quicker, and sometimes it is necessary because sometimes you cannot integrate this by hand. Okay, so that's when it would come in. So let's do this. Let's work this same problem. Notice I'm given y of 2 and I want y of 3. 2 and 3 are what values, or what kind? They are x values. So they would serve as my
intervals.
my, what are these called? Limits of integration, right? Limits of integration. So I'm going to go from 2 to 3, right? Because I always go low to high. And I would be integrating 3x squared plus 4x minus 5 dx. And by definition, that's going to equal what? F of 3 minus f of 2. Okay, so let's go ahead and do some practice with our calculator because I think that some of you have forgotten to integrate on the home, forgotten how to integrate on the home screen of your calculator. You need to be able to do that. So get whatever calculator it is that you are using. And let's, oh yeah, you got a break into it. You should be good now. I know this Okay, so if you're on an 84, remember you do this from the home screen. If you're using an Inspire, you're going to go to the calculus piece. Okay, and we are going to hit Math 9 on your 84 because that's how you integrate. All right, and my lower limit of integration is 2, and my upper integration is 3. And then I'm going to type in 3x squared plus 4x minus 5 dx. And no matter what calculator you're using, you should have gotten a value of 24. So what is this really? Tell me what this really is. Okay, what else is it? Really? Area. It is net area between this curve and the x-axis from x equals 2 to x equals 3, right? And by definition, it is equal to f of 3. Do I know f of 3 right now? No, that's what I'm looking for, right? It says y of 3. But f of 3 is what I'm solving for. Minus, what is f of 2?
Negative 1.
Negative 1. So f of 3 is equal to 23. That's the same exact thing I got up here, right? Okay.
I like that.
But I just got it from using fundamental theorem. Now this one is fine. I mean, you can integrate all of this by hand, so you could certainly do it without a calculator. But if you take a look at the next example, it says sometimes there is no closed form of the antiderivative, so we must use method 2 in our graphing calculator, i.e. you can't find the antiderivative, okay? You can't find the function whose derivative produces this. So how would I set this example up to find out what f of 1 is?
Would you go from 2 to 1?
No, you need to start, you need to go from 1 to 2 of sine of x squared dx. And by definition, that's going to be equal to what? F of 2 minus f of 1. So you're going to go to your calculator. and you're going to get a value. And that's going to be equal to, what's f of 2? Negative 5 minus f of 1 is what you're looking for, right? So I'm going to move my f of 1 over here and my 0.495 over here. So f of 1 is going to be equal to what?
You have to do like the approximation.
No. You only have to do that if they ask. The question was, do I have to do the approximation symbols? You only have to put those down when AP tells you to approximate something.
It's weird because it's not even an approximate. Like it gives you an exact answer.
Mm-hmm. I know, bizarre, huh? Any questions so far? All right, so remember we have to be able to do things numerically, graphically, algebraically, right? Sure. So let's take a look at this example on the back. We've done some problems that are similar to these, right? These will get just a little bit more complicated, I guess. So the graph of f prime consists of two line segments and a semicircle as shown on the right. Given that f of negative 2 equals 5, find f of 0, f of 2, and f of 6. Right? So where is my starting point here? At negative 2, right? And that is right here. And what is the y value that I am starting on? 5. So whatever happens from negative 2 on will be added to 5, right? Because that's your starting point. And remember, this idea of integrating a derivative produces net change in your original, right? So I've got a y value here of 5, and I want to find f of 0. Well, f of 0 will be equal to 5 plus, how could you write it using an integral? Yes, very good. The integral from negative 2 to 0 of f prime, right, because this is f prime of x. So it's important to remember what it is what this really represents, because now I know that I just need the area of that triangle. So it's 5 plus 1/2. What's the base? 2. What's the height? 4. So what is f of 0? 9. This is 1/2 of 2 times 4. Yeah, because I was just doing this triangle right here. So how would you write down how we're going to calculate f of 2?
5 plus 9.
You can do 9. You can do 5. You could do 5 plus the integral from negative 2 to 2. Or, since you just stopped right there, I can say 9 plus the integral from 0 to 2 of f prime of x dx, which is equal to 9 plus 1/2. The base is 2, the height is 4, so it's equal to 13. And then how are you going to do f of 6?
13.
13.
Integral of 2 to 6 plus the integral.
Oh, well, it's technically minus.
13
but
plus the integral from 2 to 6.
I was gonna
f prime
do-
of x.
I was gonna do plus
Minus.
and then the minus inside is how I think of it.
Okay, so you can do this one of two ways, right? So Shelby said plus right here, and she said she's just going to think of this area as being negative. So you can do it that way. Or I could put minus and just calculate that area. Okay? I don't care how you do it. Raise your hand if you would put a plus here. Raise your hand if you would put a minus there. Okay, I guess the rest of you are just not going to do it. All right, well, I got the majority of this, so I'll do that. So this is going to be 13 plus negative 1/2 base, or not, sorry, base, pi r squared over 2, right? So I'm going to have pi, and then what's the radius? 2. So that's 4, right? So this turns into what? 13 minus 2 pi. You good with that? We did some. We did some of this for sure. Okay, so you do the next one at your table. And I'm actually going to extend this problem.
Yeah, because that's how I do. Get over the little board names.
Not all of us have a massive eraser. Massive? That's massive. That's my eraser last forever.
Where's the area? Where's it? Sure. It all
Okay, and I added a part D for you.
Like this area is that
Oh, I didn't even see that. Man, what the heck? The one. Where are you putting your
And notice the areas are given to you. Derek.
My bad. Oh,
No, because you subtract before. 5 minus 1. D. And whenever you're going backwards, you put a negative sign in front of the integral. Yeah. Why are you just eating the packages of Ritz crackers? Why?
Starting my mom's going to yell at me for not having any red
Ritz are way Oh, she's not. I don't. No, 5 was 9.
I just had a better reason for it.
That's how you use the product. Okay, just make us 16. Okay. 6. Let's get to the I was at a so I had a snap of 4. There's some watered down.
Yeah, well, let's see.
We should grab the line.
I don't like this visual. Almost like there's a crap ton of stuff.
Okay, so then, wait, you have that. Oh, okay, I see what you mean. Okay, I see what
I usually just have breakfast
you mean.
Shakes.
Yeah, I wake up like 20 minutes before I leave. It depends. And that's when
After
it's usually
3.
just been showered.
It's given. The area right here is 4. The area right here is 9. Like this one started on the x-axis. This one started at 5. So it's 5 plus whatever you eat.
From 3
This
to
one,
7.
this one started at 1. It was 1 plus 9.
Oh. Wait, I got this.
So yes, it's well.
6 is it.
Yeah.
The only irrational one.
So why is he streaming?
It's not.
Why did
It's
you
giving
add
you 1 plus 4,
five?
which is 5.
No, I would love that.
You remember
On the last
question
one?
where it was like,
Okay, because I'm starting at 5, right? And when I move left, I subtract. So it's minus 4 minus negative 5. So it turns to plus.
Did she?
Did you?
She added.
Wait, how do you know that's gonna be 5? Yeah.
Yeah.
I told you.
Sorry, I was thinking, yeah, sorry.
That's okay.
But it doesn't give you explanations.
I was thinking that you were like showing us how you got it.
Oh, no. I guess I should put area equals 5.
I mean, wouldn't the area or I'm not really sure it's because we did it before because of
Yes.
How is f of 3, 5? So at point 3.
How is f of 3, 5? You were just told that.
No,
You
I know
don't.
it's given, but like you know how it says the area is 4 and that goes to point 3?
Uh-huh.
How is that? Why is it show 1 and 5? Because if it's
they just
No, because they have to give you a starting point. That's like your initial condition.
I don't know. That's supposed to
You remember all the questions are like, you're going this much, and then it changes from
before
there.
the thing
No,
starts.
it's your line.
because I didn't.
That's okay, it's fine.
So why is
You're
that?
not starting at 0, 0. These are the same.
Remember, this is a derivative, Jorge. This right here is a derivative. It's the area under this curve, this accumulation that gives you y values, okay? There's no picture of it to this point. You're just given that initial condition.
Why is it, that would be the area accumulated at
But you
point
don't, no, because you don't know where it started.
You don't start at
No,
0,
you don't know where you started.
This right here is telling you.
This is your starting point. So in other words, the bottom of your integral would have to be 3 for every single one of these.
Okay.
Your lower limit of integration for every single one of these would be 3. Okay? Okay, do I need to answer any questions for you? Yes.
For discussion graph, are we doing these straight lines or?
No.
Okay.
No. Okay, so let's see. So I know at 3 I have a y value of 5, right? So at 3, 5, I'm going to have that. I know at 0 I was at 1.
The rest of it.
I know at 7 I was at -4. I know at 9 I was at -2. And if you wanted to go over here and extend it, at -4 I was up here at 6. Okay, so what do I know is true at 0? This is good review. You have a what? No. On my original graph, I would have to have a minimum on my at 0 on my original function. I would have to have a minimum. Why?
It changes from.
Don't say it.
The slopes.
The derivative changed from negative to positive. So it has to be like this, right? And what has to be true at 3? I have to have a max. Why? Derivative changed from positive to negative. What do you have to have at 7? A minimum, right? And then what do you know you have to have right in here between 1 and 2? A point of inflection, right? And what do you have to have around 5? Another point of inflection, right? And then what do you have to have around 2, I guess? A negative 2, sorry. Another point of inflection. So something like this. And that wouldn't go over there. That would
I
stop.
forgot the 3-5 point. Don't judge me. I was ready for it.
Okay?
You believe all the hard work.
Any questions? There's a lot of talk going on at your individual tables, and that's fine if it's about calculus and you're following what I'm doing. If you're talking about other things, you're missing some important discussion. Okay, any questions on that problem? Anybody? Okay, we'll look at the next one. A pizza with temperature 95 degrees Celsius is put into degrees Celsius room when t equals 0. The pizza's temperature is decreasing per minute. Estimate the pizza's temperature when t is equal to 5. So I started at some temperature, right? And what equation did they give me? The
CE to
right, but what is it? It's the
exponent.
I don't care about that. Tell me what it means.
The rate.
It's the rate
It's cooling down.
at which the pizza's temperature is changing, right? It's the rate at which my pizza's temperature is changing. Okay? So what do I need to do with that equation?
What was the place in Texas called Sugarland?
Plug the 5 minutes.
I didn't know that.
Okay? Why? I need to integrate it. Why?
Because that's the reason you need.
You need the actual.
Because when I integrate it from point A to point B, I have found the
Original function. Particular solution. No, don't do the accumulation.
accumulation of the temperature change, right? Were you saying that, Jenny?
I'll say numbers.
Okay, numbers. Okay, Carson was getting there. Okay, yes, what you found whenever you integrate it is your total change in temperature. Okay, some people refer to the fundamental theorem of calculus as the total change theorem. So when you integrate the rate of change equation over a time period, what you have really found is the total change, okay, or the accumulation in change. So, I have my, let's see, we'll go from 0 to 5 of r of t dt. And I'm going to show you this trick just to, I've mentioned it before, but I'm going to show it to you again because as in this chapter, we're going to start getting into equations that are really complicated to type in your calculator. And the fewer times you have to actually type them, the better off you're going to be. So what I do a lot of times in problems like this, now granted this only has one question, but most of the time you're going to be asked multiple questions that involve this equation. I'm going to put this equation in y1, and I'm going to call it, or I'm going to say 6e to the negative 0.15 t. And now I can call that up anytime I need it. And again, this one you only had to type it one time, but I just want to familiarize you with what it looks like. Okay, so I'm going to go math 9. And I'm going to integrate from 0 to 5. And I'm integrating what I just typed into y1. So if you go alpha trace, you just call up y1. And I'm doing that with respect to x. And so I hit enter, and I can see that the accumulation, my temperature change, the net change in temperature is what? 23.608 degrees, right? Now what has that done? It has gone down. How do you know that? Okay, so if I take 95 and I subtract what I got there, that will give me the new temperature.
So if it had increased, then you would add it.
Mm-hmm.
What is the 25 degree where you have to do it?
So that you know it's decreasing.
Okay.
And it wouldn't go below.
Yeah, and it wouldn't go below it.
Am I the only one? No.
So we're going to start using the fundamental theorem to answer questions that involve a total change. What time is it?
19.
19? Okay, great. Okay, so your homework. I really want you to do all 17.
But
Okay, is 1 through 17. The directions for 1 through 3 say to work the problems using both methods. You do not have to use both methods. Okay, and it shouldn't take you very long. You definitely need a calculator for your homework. If there are any of you that do not have a calculator and you need to check one out, please see me. Okay? But you're going to want it. You're going to need it this entire chapter. The test over chapter 7 is all calculator. Don't everybody fall down at once.
It's been so long.
I know.
That one time when we were like, oh, you get to use calculators on a quiz, and it's like,
Well, we're in chapter 7 and you finally get to use it for a whole test. No, let me write down what number it is.
Number 26.
Okay. Let me stop this.
hey,